Welcome, guys, to another lecture on thermodynamics. The topic today will be zeroth law of thermodynamics and thermal equilibrium. Today, we will discuss what is a steady state, what is thermodynamic equilibrium. We will talk about the zeroth law and we will try to give some explanations what a zeroth law is. So, to begin with, what is a steady state? We may ask ourselves. So, if the property of a system at any specified location are independent of time, then the system is said to be in a steady state with respect to the property. So, what happens here? Mathematically, if we speak, at a steady state, if we are observing some property, let's say m, then when we take the time derivative of m, we find that it to be 0. That is, dm dt is equals to 0. So, the property is unchanging with time. To give an example, if say we are filling up a bathtub with the tap open and there is no bottom plug which prevents the water from leaking out. So as the water is pouring inside the tub, a portion of it is leaking out from the bottom. So after a certain time, we will observe that the rate of the filling of the tub will equal to the rate of the leakage from the bottom. So the rate at which water is filling the tub will be equal to the rate of leakage that is draining the tub. And at that moment, we will see the liquid level to remain unchanged with time. So here the state variable being V, which is stabilizes and the system is at steady state. Moving forward, so what is a thermodynamic equilibrium then? Thermodynamic equilibrium is a condition or the state of thermodynamic system, the properties of which do not change with time. So, as far as not changing with time concerns, we are on par with the steady state. But the difference here is if we want to change the properties, what we have to do, we have to bring some subsequent change to the connected systems or the surroundings. There will be effects on the systems which are connected to the system under study or the surroundings. So, a thermodynamic equilibrium is a state of physical system in which it is in mechanical, chemical and thermal equilibrium and in which there is therefore no tendency for spontaneous change. That is, no tendency for change without the aid of external agency. What is mechanical, chemical and thermal equilibrium? We will cover in later chapters. At least we will talk about thermal equilibrium in this chapter and in this very lecture for a bit. So when a system is in a thermal equilibrium, there is no tendency for the system to change itself without any aid from external agency. Now, keeping in the mind the steady state and the thermodynamic equilibrium, let us discuss what the zeroth law of thermodynamics is. The zeroth law of thermodynamics states that if two bodies are each in thermal equilibrium with some third body, then they are also in thermal equilibrium with each other. The zeroth law of thermodynamics states that if two bodies are each in thermal equilibrium with some third body, then they are also in thermal equilibrium with each other. Thermal equilibrium, what does thermal equilibrium mean then? Thermal equilibrium means that when two bodies are brought into contact with each other and separated by a barrier that is permeable to heat, I mean there is a possibility of heat transfer between the two bodies. A time will come when there will be no net transfer of heat from one body to another. A time will come when there will be no net heat transfer from one body to another. So this says in essence, the zeroth law, what it says, that the three bodies are all at the same temperature. The three bodies are all at same temperature, and there is no net heat transfer from one body to another. So something needs to be understood here. How do we sense heat? We sense heat by, say, something is appears hot to us and something which appears cold to us. But that is very arbitrary. We measure or sense heat using a thermometer. And what does a thermometer actually measure? It measures temperature. So temperature is a measure of heat. Temperature is it is not the total heat, but it is a measure of heat. Now, when temperature of two bodies, interconnected bodies, are same, there will be no net heat transfer. Now let us put another body into the mix, three interconnected bodies, and each having same temperature, so there will be no net heat transfer from one body to another. That means the three bodies are in thermal equilibrium. So the zeroth law basically indicates or tells us what a thermal equilibrium is, and in essence it also says what thermal equilibrium means. So what we get from it, we get the idea of temperature from the zeroth law of thermodynamics. The zeroth law of thermodynamics gives us or hints us a parameter which is measurable and which can indicate thermal equilibrium, which is nothing but the temperature. So let us look into the following diagram. We have three bodies A, B and C. All are interconnected, and zeroth law says A is in equilibrium with B and B is in equilibrium with C. Which kind of equilibrium? Thermal equilibrium. Now A and C are interconnected, so they must be in thermal equilibrium. This is the explanation of the zeroth law. If we look into it mathematically, so let us consider three interconnected bodies A, B and C, whose respective temperatures are TA, TB and TC. Okay. Now A and B are in thermal equilibrium, hence we can write, what can we write? That TA is equals to TB. A and B are in thermal equilibrium, so their temperatures must be same, so TA is equals to TB. Again B and C are in thermal equilibrium, so what can we write? We can write that TB is equals to TC, as thermal equilibrium means being of the same temperature. Now from equation 1 and equation 2, what can we write? TC is equals to TA. It is very obvious. So what can we say? Since A and C are interconnected and they have the same temperature, we can conclude C and A are also in thermal equilibrium. This is essentially the explanation or proof of the zeroth law of thermodynamics. We know that there are three laws, but actually there are four laws in thermodynamics: zeroth law, first law, second law and third law. We will cover them accordingly. One thing to remember, that these laws are thermodynamic laws are intuitive. There are mathematical explanation there, but they are not result of rigorous derivations. These are intuitive laws. These are based on or statements on observed facts. So these things we have to remember while dealing with them. So that's all for today. Next we will start discussing the first law in our subsequent lectures. Thank you for joining.